Today we're going to look at the final topic in Chemistry 3202. That would be Faraday's law. According to Faraday's law, the amount of a substance produced or consumed in an electrolysis reaction is directly proportional to the quantity of electricity that flows through the circuit. Basically what this means is we can look at a reaction or a half reaction where the number of electrons are included, and the number of electrons is stoichiometrically related to the other species in that half reaction, meaning we can do stoichiometry with a half reaction. Before we can do that, we need to get through several terms. Electric current is the flow of electrons through an external circuit. It is represented by a capital I. It has the units amperes or a capital A, meaning I can say that the current is equal to, say, 2 amps. Electric charge is represented by capital Q, and it means the quantity of electricity. It is the product of the current flowing through a circuit by the amount of time that it flows for. It has the units coulombs or capital C. Therefore, I can have a charge equal to, say, 1,000 coulombs. A coulomb is the quantity of electricity that flows in a circuit in 1 second if the current is 1 ampere. This relationship can be shown by the equation where charge is equal to current times time, where time has to be in seconds. This equation is given to you on your formula sheet. For example, find the quantity of electricity that results from a current of 3.50 amps flowing for 6 minutes. So when they say find the quantity of electricity, they're looking for Q. When given a current, that is I, and any sort of time is T, we just need to make sure that we convert it to seconds first. So we write the formula Q equals I times T. Current is 3.50 amps, and time is either 6 minutes times 60 seconds per minute. You can convert it right in the question, or you can do that over to the side if you want, and then plug it back in. Doesn't matter. The equation for an electrode reaction relates the number of moles of substance consumed or produced during the reaction to the quantity of charge that passes through the cell. For example, if we were to look at this half reaction, we can see that in order to produce 1 mole of solid silver, we need to have at least 1 mole of electrons with 1 mole of silver ions. Likewise, if we were to look at the half reaction for gold, in order to produce 1 mole of solid gold, we would need 1 mole of gold ions and 3 moles of electrons. So to perform stoichiometric calculations for electrochemical and electrolytic cells, we also need to know the charge on 1 mole of electrons. The charge on 1 mole of electrons is 96,500 coulombs. In calculations, we use 96,500 coulombs per mole, and this is known as Faraday's constant. Note that this number only has 3 significant figures. The 2 zeros at the end do not count. We can now link this together with the equation where the number of moles of electrons is equal to the charge divided by Faraday's constant, or the charge divided by the charge per mole of electrons. Note that this is also given to you on your formula sheet. Therefore, in this lesson, we've been introduced to 2 different formulas, where the number of moles of electrons is equal to Q divided by F, and Q is equal to I times T. If we were to take Q equals I times T and take I times T and fill it in here for Q, we would also make the formula number of moles is equal to IT divided by F. This formula, however, is not given. However, you can very easily derive it from the 2 given formulas. Or, with enough practice, it's something that will be easily remembered. To put this all together, we can calculate the mass of any electrolysis product. The steps involved in doing this is number 1, to find the number of moles of electrons, using either number of moles of electrons is equal to IT over F or Q over F, depending on the information given to us. Once we know the number of moles of electrons, we can then go to step number 2 and use stoichiometry to figure out the number of moles of what we're trying to find the mass of, where number of moles required is equal to number of moles given times required over given. Once we have the number of moles required, we can then find the mass. For example, calculate the mass of zinc plated onto the cathode. So we're looking for this mass right here of an electrolytic cell by a current, or I, of 750 milliamps in a time of 3.25 hours. Therefore, the information that we know the current, 750 milliamps, which is converted to amps by dividing by 1,000. We know the time is 3.25 hours, but we must convert that to seconds. And we always know Faraday's constant is 96,500 coulombs per mole. Recall that step number 1 is to find the number of electrons, or number of moles of electrons, using either IT divided by F or Q divided by F. Given the fact that we have I, T, and F, we're going to use the equation number of moles of electrons equals I, T divided by F. When we do that, we get an answer of 0.0909 moles of electrons. Once we know the number of moles of electrons, we can find the number of moles of what we're required to find using stoichiometry, where our given is the electrons and the required is the solid zinc. Once we know the number of moles of our required, or our solid zinc, we can then use that with the molar mass of zinc to find the final mass. Let's try this style of question on our own. How many grams of gold, so we're looking for mass of gold here, will be deposited when 5,000 coulombs, so charge has the units coulombs, so we know Q, 5,000 coulombs, pass through a solution by the following equation. Well, step number 1 is always to find the number of moles of electrons. We cannot use IT divided by F here because we do not know I or T, so we need to use Q divided by F. Q is 5,000 coulombs. Faraday's constant is always 96,500 coulombs per mole. This will give us 0.0518 moles of electrons. Once we know the number of moles of electrons, we can find the number of moles required, in this case solid gold. It's equal to the number of moles given, which is the number of moles of electrons, times the coefficient required, here that would be 1, over the coefficient given, that would be the number of electrons, or 3 moles of electrons, to give us 0.0173 moles of gold. And then we can answer the question. We're looking for mass. Mass is equal to the number of moles times the molar mass. The number of moles we just found in step number 2, 0.0173 moles of gold. We find the molar mass of gold on the periodic table to be 196.97 grams per mole, to give us a final answer of 3.41 grams. Let's try another one. Calculate the number of moles of magnesium produced when a current of 60 amps, so I equals 60 amps, is passed through a magnesium chloride solution for a time of 4 hours. Well, the first thing that you can do is remember that time has to be in seconds, so we'll multiply this by 60 minutes per hour and 60 seconds per minute to give us 14,400 seconds. Step number 1 is to find the number of moles of electrons. Here we're going to use IT divided by F, since we know the current, we know the time, and we always know Faraday's constant. So we have 60 amps times 14,400 seconds, all divided by 96,500 coulombs per mole. This will give us an answer of about 9 moles. So this is a very poor question as it relates to significant figures. Then we can find the number of moles of magnesium using stoichiometry. We have 9 moles of electrons times the coefficient required, which is 1 mole of magnesium over 2 moles of electrons, which gives us about 5 moles. And we're done this question. The last example I will go through. How many hours will it take for a 3.50 amp current? So we know I equals 3.50 amps. To electroplate 129 grams of gold. So this mass here is 129 grams of gold, according to this equation. Well, this one's a little bit different from the ones we've done, and therefore we cannot do step 1, finding the number of moles of electrons, because we don't have enough information. So you should ask yourself, what do we have enough information to find? And considering the fact we have the mass of gold, we can find the number of moles of that using mass over molar mass. We have 129 grams. We look up the molar mass of gold on the periodic table. It's 196.97 grams per mole to give us 0.655 moles. Now that we have the number of moles of gold, we can find the number of moles of electrons using stoichiometry. The number of moles given times the coefficient required. We're required to find the number of moles of electrons. That has a coefficient of 1. We're given information about solid gold that also has a coefficient of 1, so the number of moles does not change. Once we have the number of moles of electrons, we can find the amount of time. Recall that number of moles of electrons is equal to IT divided by F. If we were to rearrange this for time is equal to, we would have the number of moles of electrons times Faraday's constant, all divided by I. So we have 0.655 moles times 96,500 coulombs per mole, all divided by 3.50 amps. This will give us a time of 18,059 seconds. We have to write this according to the appropriate number of significant figures, so that would be 1.81 times 10 to the 4 seconds. Or if you want to, you can write it as 5.02 hours if you prefer to convert it to hours for the significant figures. Hopefully you have a clear understanding of Faraday's law after this lesson. This is always on the public exam as well, so you're guaranteed to have a balancing and acidic or basic solution and or a Faraday's law. It's very rare that it's not on the public exam. So at this point you can give the worksheet a try.